Alright, thanks for watching, and today I would like to do something pretty fun. Namely, I want to give you a little bit of intuition behind L'Hopital's rule, but also a little proof, and I end with a scandal about L'Hopital's rule. It's pretty exciting, you'll see. So again, what does L'Hopital's rule say? It says that if you have a limit of the form infinity over infinity or 0 over 0, then the limit of the functions, of the ratio to two functions, is the limit of the ratio of the derivatives. That's what L'Hopital's rule says. And first, let me give you a little bit of physical intuition. So suppose it's Formula 1 and you're witnessing a car race between two cars, where this is time and this is the position. And again, you have two cars. They start initially at 0, so they both start at this point here. But then the first car accelerates to 50 miles per hour. So that's car 1. But then the second one accelerates to 100 miles per hour. This is car 2. Without knowing any more info, can you give me a guess as to which car will win? Well, at least initially, it seems that the second car wins. And the question is, how did we figure that out? We didn't really talk about the positions, which is, because they were all 0, we figure it out by comparing the relative velocities. And this is essentially what L'Hopital's rule says. If you want to compare the positions of two cars, assuming they're 0 at 0 or something, then all you need to do is compare the velocities. So here what happened was the velocity of the second car was bigger than this one, so that was really small. Therefore, the relative positions of the two cars is also very small. So I feel at least physically it should make sense, but it turns out it also makes sense geometrically. Because consider the following thing. Again, suppose you have two functions. Let's call them, function 1, so f if you want, that goes like this. That is f, and that is g. And this is not initially, but let's say at the point A. Now of course, it looks like, function f is bigger than function g, but that's not the point of it. The point is, well, those are kind of hard to deal with because they're 0 at 0, but an easier object to deal with is the tangent line of the function. So here's a tangent line of f, and here's a tangent line of g. And notice, at least near the point A, those tangent lines become indistinguishable. So this one looks kind of like f, and this one looks like g. So what L'Hopital's rule is saying is that instead of comparing the relative positions of the functions, so f over g, just compare the tangent lines. And more precisely, let's compare the slope of the tangent lines. Well, at the point A, the slope here is f prime of A. And the slope here is g prime of A. So for instance, if this one is 2 times bigger than this one, you could also say f is roughly 2 times bigger than g. So in other words, what this is saying, to figure out how f compares to g, just figure out how what f prime of A is compared to g prime of A. At least approximately, and that is if you want, in some circumstances, the same thing as the limit of the ratio of f prime and g prime. And in fact, that will hint to a proof of L'Hopital's rule. So let me give you a little sort of, not 100% mathematically rigorous proof, but at least a good idea of why it's true. So here let's assume, again, just for simplicity, f of a is 0 and g of a is 0. Then here's a neat little trick. Limit x goes to a of f of x over g of x. That's the same thing as the limit as x goes to a. And here's a little trick, because ultimately we want to write this in terms of derivatives. Let's divide this, both sides, by x minus a. And then what this looks like was almost like slopes. So that is limit x goes to a of something and limit x goes to a of something, because we assume the limits exist. And this is f of x over x minus a and g of x over x minus a. But remember, f of a and g of a are 0. So this is f of x minus f of a and g of x minus g of a, which now you may recognize as derivatives. So this is f prime of a over g prime of a. And again, under a lot of circumstances, this is the same thing as the limit of the ratio of the derivatives. So this is a simplified proof of L'Hopital's rule. Of course, we did this special assumption where f and g are 0 at a, and also it's not always true that you can just pass in the limit like that. But at least in this case, that's true. And last but not least, you may wonder, what is the scandal? Well, the scandal is, it turns out L'Hopital didn't come up with L'Hopital's rule at all. It turns out, at least historically speaking, he had a very smart student, Bernoulli, right, like the Bernoulli trials, and it turns out Bernoulli came up with it, but L'Hopital was his teacher or his master at the same time, and then he just took credit of it, just like that. I know, speaking of injustice, but at least we have L'Hopital's rule, so that's nice. At least we have one little rule. Alright, I hope you like this. If you want to see more math, please make sure to subscribe to my channel. Thank you very much.